Question number 11. Figure shows xt graph of the particle. Find the time t such that the average velocity of the particle during the period 0 to t is 0. So for this purpose, if difference in displacement, that is final and initial displacement, will be same, in that case, average velocity will be 0. So we try to find initial displacement here. This is 20 meter, and here at this point, again displacement becomes 20 meter. So we have to find out the corresponding time for this purpose. So time corresponding to 20 meter is 12 seconds. So here, if we find average velocity, so net displacement will be 20 minus 20 divided by time. Time is 12 minus 0, which is 0. So we can say that IT t equal to 12 seconds. Average velocity of particle is 0. Question number 12. A particle starts from a point A and travels along the solid curve shown in the figure. Find approximately the position B of the particle such that the average velocity between the position A and B has the same direction as the instantaneous velocity at B. So direction of instantaneous velocity at B will be like this, in this direction towards C, and average velocity can be found by joining A and B. So let's join it. The two velocities, instantaneous velocity and average velocity. And instantaneous velocity and average velocity will have same direction at this point, because as per question, find approximately the position B of the particle such that average velocity between position A and B has the same direction as the instantaneous velocity at point B. So here we have joined it to a line. Now, so what can we say here? This point is to be found. So the point corresponding to point this will be value of x corresponding to point P is 5, and the value of y corresponding to point P is 3. So we can say it is point B 5, 3, where instantaneous velocity equals average velocity. Because direction of average velocity will be this. If we write average velocity, it will be vector AB upon T, which is in same direction as the instantaneous velocity at point P. Question number 13. An object having velocity 4 meter per second is accelerated at the rate of 1.2 meter per second square for 5 seconds. Find the distance traveled during the period of acceleration. So S equal to ut plus half at square, u equal to 4, a equal to 4 meter per second, a equal to 1.2 meter per second square, and t equal to 5 seconds. So we can put the values here. So 4 into 5 plus 1 by 2 into 1.2 into 5 square. This will become 20, and this will become 0.6 into 25. So this will give 35 meter. Question 14. A person traveling at 43.2 kilometers per hour applies the brake, giving a deceleration of 6 meters per second square to his scooter. How far will it travel before stopping? Simple question. Here V, final velocity will be 0. Initial velocity is given 43.2 kilometers per hour, which will be equal to 43.2 into 5 by 18 meter per second. So if we evaluate it, it will become 12 meter per second. We have got the value of U. Acceleration is -6 because this is this deceleration, meter per second square, and we have to find out S. We have formula V square equal to U square plus 2AS, or S equal to V square minus U square divided by 2A. So S equal to 0 minus U square. U square means 12 square divided by 2 into A. A is -6. So this will give 12 meters. Question 15. A train starts from west and moves with a constant acceleration of 2 meters per second square per half a minute. The brakes are applied. The brakes are then applied and the train comes to rest in 1 minute. So this is the situation. This point corresponds to portion where there is acceleration, and then from A to B, brakes are on. So that is why there is deceleration, and corresponding to 90 seconds, train comes to rest. Now we have to find out total distance moved by the train. Second point, maximum speed attained by it. The position of the train at half the maximum speed. So let's evaluate it. First of all, we can find the maximum speed up to here. So we can apply formula V equal to U plus 80. So V will be equal to U is 0, and A during this period will be slope of this. So slope is 60 minus 0 divided by time corresponding to it, 30 minus 0. That is 2 meters per second square into time. Time is 30 seconds. So V equal to 60 meters per second. This is answer to part B. Maximum velocity or maximum speed. Now, to get total distance traveled, we can find the area of the triangle OAB. Total distance equal to half base into height. So base is 0 to 90, that is 90, into corresponding height is 60. So this will become 2700 meter. Now, position of the train at half the maximum speed. So here, this is one point where speed is half, and this is also one point where speed is half. So we have to find out the corresponding position. So let's evaluate it. So we apply formula. Speed is half means 30. When V becomes 30 meters per second, in that case, what is the time? So this time this is to be evaluated. So let's evaluate, and this will come out to be 15. That's why here 15 is 10. And similarly, this time is to be evaluated, and that will come out to be 60. So let's see how. So we apply formula V equal to U plus 80. During this time, we have evaluated acceleration as 2 meters per second square. So we put the values. Speed is 30, initial speed is 0, plus 2 into t. So this gives t equal to 15 seconds. So that is why this is written here 15. and here speed becomes half, that is 30 meter per second. Similarly, we have to find out time corresponding to this point where speed again becomes half during deceleration. So again, we can apply formula V equal to U plus 80. So here V is 30, initial speed is 60. And what is acceleration during this period? This will be negative acceleration. So we can find it. A will be final speed becomes 0. Initial speed is 60 and divided by corresponding time 30 to 90 means 60. So it will be minus 1 meter per second square. So we can write here minus 1 times t. So here, if we evaluate, so we will get t equal to, this will be minus, so t will be 30 seconds. So we are starting from here till here. So 30 seconds after this 30 seconds, it means it is 60 seconds. So T2 is 60 seconds, starting from rest. Now we have to find out the position of the train at half the maximum speed. So corresponding to this point when time is 15 seconds and corresponding to this time when time is 60 seconds, we have to find out the position of the train. So for that purpose, let's evaluate it. So when t equal to 15 seconds, then what is corresponding distance? So s equal to ut plus half 80 square. So u is 0 plus half. Acceleration during this period is equal to 2 meter per second square. So 2 into time is 15 square. So this will come out to be 225 meter. Now we have to find out distance traveled corresponding to this point. So there are many ways to evaluate it. Like we evaluate the triangle OAC, its area, and then trapezium AC. Suppose this is G, this is C. So let's evaluate it. So this was S1, now S2. So we can try it 1 by 2 area of triangle. So 1 by 2, 30 into 60. This portion plus area of trapezium, sum of parallel sides into half into 1, sum of parallel into height. So here sum of parallel sides is corresponds to 60, this corresponds to 30. So 60 plus 30 into separation, that is perpendicular distance, so that is 60 minus 30. So it is 30. Now, we will cancel this 30 by 15 times, and this will cancel 15 times. So this will become 900 plus 90 into 15. So 900 plus 1350, which will give 2250 meter or 2.25 kilometers. And that is our answer. Thank you for watching.